Let's take another look at an example where we are going to do a hypothesis test for a population proportion with a single sample. So here, our example, we have a poll of 806 adults found that 492 prefer the window seat to the non-window seat when they fly. We want to use a 0.01 significance level to test the claim. What are we testing? That the majority of people prefer the window. So that's the claim. Let's write that claim symbolically. So the claim is that the proportion of people that prefer the window seat is the majority. The majority is more than 50%. And so the counterclaim, the opposite of this, is nope, it's not more than 50%. If it's not more than 50%, it's less than 50%, or it's equal to 50%. So that is the counterclaim. Once we've identified those two things, we can identify both the null and the alternative hypothesis. The alternative is always one of these two, either the claim or the counterclaim. It's the one that does not allow the two sides to be equal. So in this case, it is that alternative hypothesis matches up with the claim. If you remember back to our last video, our alternative hypothesis matched up with the counterclaim, matched up with the opposite. So it's not always coming from the claim or the opposite. It's not always coming from one or the other. It could come from either one of those. Our null hypothesis always has an equal sign, so we're going to say the proportion is equal to 50% as our null hypothesis. For this hypothesis test, this is a one-tailed test because the sign here, that sign is a greater than sign, so it's a one-tailed test. In particular, it is a right-tailed test. We can also identify from here, we are given the value of alpha, the significance level. We are given the value of n, the sample size is 806. And the number of successes, we're considering a success here if they prefer the window seat. And so 492 of those 806 prefer the window seat. So we're going to take these values and throw those into StatDisk. So here we are in StatDisk. We are going to choose analysis. We are choosing a hypothesis test. We want to test a hypothesis about a proportion with one sample. Something that's really easy to overlook here is we first need to select the alternative hypothesis. And so our alternative hypothesis was that the proportion was greater than some claimed value. So that second option, number 2, we claim that the population proportion is greater than a claimed value, greater than 50%. That's the alternative hypothesis. Our significance level there was, I believe, 0.01. We'll double check this in a minute. The claimed proportion, the proportion from the null hypothesis, is that it's actually equal to 50%. Our sample size was 806. And the number of successes was 492. So we can evaluate that. Let's go back and double check that. So 806 as our sample size. 806, we got that right. Number of successes 492, and our value of significance level, or value of alpha, is 0.01. We have a greater than sign for our alternate hypothesis. Perfect. So all of those things look okay. Using a p-value method, so down there we see a p-value of 0.0, sorry about that, 0.000. That is our p-value. With the p-value method, what we want to do is we compare the p-value to our significance level. And so we observe that our p-value 0.000 is less than the value of alpha. And so if the p-value is low, the null must go. So we reject the null. There is evidence of the alternative. What is the alternative? Well, you come back up here and you say the alternative is there is evidence that the proportion is more than 50%. In terms of a graph of a normal distribution, the idea here is we have this normal distribution of things that might have happened if we assumed that the proportion was actually 50%. We said if we were up here in this 1% up at the top, we didn't care if it was too small. We only had the alternative if it was too big. So we said if we're in that top 1%, we're going to reject it. The sample that we happen to get, it had something like this, where the area was 0.000, was less than 1%, so it's living in this tail somewhere. And so that's why we reject the null hypothesis. We are in that region of rejection. We can also see this by thinking about the critical value method. We can think about the critical value and the test statistic. So let's look at the critical value. Our critical value is 2.326. We just have one critical value. It's a z-value, 2.326. We have our test statistic. I don't remember what it was exactly, but it was 6 point something. Let's go back and look. So our test statistic was 6.270 if we round to three places, 6.270. And so if we think about this as a normal distribution again, what we have done here is we've said our critical value is right here, 2.326. We would reject it if we were more than 2.326, only if we had values greater than it. Our test statistic that we happen to get, it was 6.270, so that would show up way over here. And so since that's in the region of rejection, we reject the null hypothesis. We are saying that there is evidence of the alternative. And then our last method that we could use is a confidence interval method. With our confidence interval method, Here we get a confidence interval down there that says the value of P is between 0.570 and 0.650. And so we want to know, based on this confidence interval, could we confidently say the alternative? Could we confidently say that the proportion is more than 50%? And so, yes, we can confidently say the alternative, that is more than 50%, because the entire confidence interval is above 50%. So we reject the null. There is evidence that the proportion is more than 50%. Right? There's evidence of the alternative. Perfect. In the next couple of videos, what we're going to do is we're going to look at similar kinds of ideas, but we're going to do hypothesis tests for means in our next couple of videos. We'll talk to you then.